Welcome to section 1.4. This is a more geometry-based type section where we're going to be rewriting formulas, and I'm going to start you off in that geometry mindset of using a formula to get some relevant information. Only I'm going to take it the Algebra 2 way, where more that I care about the equation than I do the actual answer. And then I'm going to show you the two types of equations that are absolutely necessary for what we're doing in Algebra 2. So here we go. I want to start first with what the heck a formula is. A formula is just basically an equation, except in our normal equations we only deal with one variable, and a formula says, well, let's talk about 2, 3, 4 different variables and just rework things. Okay, so our goal for today is just to basically start taking these formulas and just moving things around so that we get the information that we're looking for. So I'm going to start with number 1. Now, number 1 says C equals 2 pi r. And if you remember from geometry, this is the formula to find circumference of a circle, where r is the radius and then c is the circumference, and we know it's 2 pi around a circle. Now, their goal is, instead of having your equation say c equals, let's instead make it say r equals. And so our goal at the end is to come up with an equation that says r equals something. So I'm going to start, okay, I have this equation, c equals, or formula, 2 pi r. Now, if I want to keep the r, I want to move the 2 pi. Now, instead of doing this in multiple steps, I'm going to do this in one. Well, 2 pi is being multiplied by r, so to get rid of multiplication, we divide. So we divide this side by 2 pi, and we divide this side by 2 pi. And again, anytime I do something, I try and cross off so that I know I've gotten rid of it. And what you'll notice now on the right side is that r is by itself. So I look at this and know that r is the same thing as circumference divided by 2 pi. And this is what I'm looking for. Now, I will tell you that in every question they're going to ask you a second part. Like, what is the radius if the circle has a circumference of 26? Well, all I need to do then is take the circumference of 26 and divide it by 2 pi. And what I'm going to do a second is kind of look at this and say 26 divided by 2 is 13. And if I look at 13 over pi, I'm going to stick this in my calculator because I don't know what this is. You end up getting about 4.14. I need a label, meters, because they gave me a label to start with. And so you can use your calculator in part B, but in this part A of everything, or as we start going through, my personal thing is I prefer that I basically want to see your new formula, and I could care less about the plug and chug stuff, okay? And so I'm going to talk about that more when we get in class tomorrow, but I at least want to give you this idea. Now, the second formula is for converting between Celsius and Fahrenheit. So we're talking about temperature. So if you've taken a biology class or chemistry or whatever, you've probably seen this formula. Now, instead of this being for F, they say please make it a C equals equation. Now, I got to be honest, you'll see kind of as I'm walking through this, I start with what I need it to end, and I give myself some space, and then I walk through that above. And I'm just showing you that because, again, I need to know where I'm going to end, so I'm going to put that first. Now, as I look, they say F equals 9/5 times the Celsius plus 32. Now, I'm going to pretend that F is just another number for a minute. And as I look at this, I'm going to solve, so I'm going to do the opposite. And we said do PEMDAS backwards. So I'm looking at addition and subtraction, multiplication and division, exponents, and then parentheses. Well, I don't have parentheses or exponents, so I'm going to go back and I'm going to say, okay, addition and subtraction. Well, I'm going to get rid of my 32, so I'm going to subtract 32. My question is, can F and the 32 actually combine to get one thing? And because F is a variable and 32 is a number, they can't combine. So I'm just going to leave it as F minus 32 equals 9/5 times C. Okay, again, I'm going to look at the right-hand side because I'm trying to find C. How do I get rid of the 9/5? Well, it's being multiplied, so you could divide it, but we don't really divide by fractions. It looks kind of ugly. So instead, we multiply by its reciprocal so that the 9's cancel and the 5's cancel. And I need to do this on this side as well. Let me put it in the correct order a minute. So we need 5/9. Now, there were two things to start with on the left-hand side. So this multiplication has to go to both. The easiest way to do that is just to put a parenthesis around so that the 5/9 does go to both quantities. So my formula now is that the circumference equals 5/9 times Fahrenheit minus 32. Now you could distribute that out if you wanted, but there's no point. For me, this is perfectly fine. Okay, and again, you can use your calculator to plug 85 degrees in. You end up getting about, I think it's 29.4 degrees Celsius, something like that. I mean, go ahead and try it. Make sure you can get something like that. But at this point in time, again, my main concern is that you can change the formula, not necessarily find a number answer. Okay? So those are the geometry versions of what we are asking you to do. Now I want to transition into the algebra versions of it. And we're going to do just a couple, and then we'll do some in class as well. So let me slide this to the down to the bottom. I've written these examples to read exactly the same way as they do in your book. And I want to point this out because I want you to know what's coming. What the directions will say are solve this formula or this equation for a variable. So that means in the end, like number one, I want to get something that says y equals. But it says then. Then means it's a secondary question. So really, there's a part A and a part B. That means on your homework tonight, even though it's only like 7 or 9 questions, you really have a part A and a part B. So you're really kind of doubling your work there. So I want you to be aware of that. So I personally just write A and B. Okay, if I'm looking at part A, I got to solve for y. So 5x minus 4y equals 9. Okay? If I want to keep the y, then I need to move the x. And if the x is positive, in order to move it, we subtract it. So I'm going to subtract 5x on either side. The left-hand side, I still have negative 4y. In the right-hand side, take a look. Can you subtract 9 minus 5x and get an answer? Well, 9 does not have an x. Therefore, they are not like terms. So my answer for this, my closure property has to still say 9 minus 5x. Now, if they both had an x, we could discuss what happens, but in this case, it has to stay the same. The next thing we're going to do is get rid of the negative 4 in front of the y. So because these two are being multiplied, I need to divide by negative 4. And what I want you to do is to divide each quantity. And if you can divide each quantity right now, then when we do chapter 2, you're already going to be in the correct mindset. So I want to start it right away. The 4's will cancel out. All right, 9 divided by negative 4 cannot be reduced. So we're going to write this as negative 9/4. Okay, and then second, I have a negative divided by a negative makes a positive. 5/4 can be reduced, so 5/4x. You can leave the x on top, you can put it on the side. Placement to me is not that important. So here's part A. Once I have an answer, then I can actually plug it in. So my part B now will say use this equation and find the answer, the one answer, when I plug a negative 3 in. Well, 5 times negative 3 is negative 15. So negative 15/4 plus negative 9/4 They have the same denominator, so I add the numerator. Negative 9 and negative 15 is negative 26 fourths. And if you leave your answer here, I will deduct some points because it is not in lowest form. I can divide each of these by 2 to get negative 13 halves. Now in this case, is it okay to say negative 6.5? The answer is yes, because it's a nice decimal. If your decimal does not end or does not repeat, you may not leave it. Okay? So that's the first type, and this type is really our big chapter 2 type. I mean, this is where we're really trying to get ourselves into chapter 2 already. And it should be something that you did in Algebra 1 and even in some of the Geo. The second one vamps it up a little bit, okay? We're asking you to solve for y again. Here's our problem. If you look at the last equation, there was only one y. But our second equation, I have two y's. Bummer there. Okay, so here's what we're going to do. We're going to do an idea called back distribution. And what that means is because they both share a y, I'm going to pull that y out of each of them. And let me show you what that looks like. As I do 8, let's pick the right letter, shall we? As I do 8y plus xy equals 10. If I take a y out of this one, what do I have left? If the y is gone, the only thing that's left is the 8. Plus, if I take the y out of this one, the only thing I have left is the x. Now take a look. We call this back distribution because normally distributive property looks like this. Something's out in front and you take it and share it to both. Well, if I took it and share it with both, wouldn't it look like this? The answer is yes. So we're basically undoing whatever distribution was already done. And I'm going to finish this because now here's what happens. This y times this whole quantity. And how do I get rid of the whole quantity if it's being multiplied? Well, the opposite of multiplication is division. And so we're going to divide by that whole parentheses on both sides. So my final answer for my new formula, because these will cancel out, is 10, y equals 10 divided by 8 plus x. From here, I think you could then, if that's part A, I think you could plug in a -6 and find b. But I so don't care so much about that as I do getting to the formula. And I'm going to practice actually another one of each of these because I feel like it's that important. So here's what we're going to do. Flip the page. At the bottom of the next page is some extra examples, and I want to work on these for a moment, and we'll kind of come back to getting our way around. But if you look at the back, here's what I'm going to do. Take a look at number 4, because I'm asking you in number 4 to solve for y. And the reason I like number 4 is not only is there one y, but there are two y's. This is coming back, hint, 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 on a quiz or a test. Okay? Now, if they both have a y, by the process we've done before, the back distribution, I'm going to take the y out of each. If I take the y out of the first quantity, or the first term, I'm left with a 2 and an x. Then I have the subtraction sign. If I take a y out of the second term, the only thing that would be left is the 5. Set it equal to 8. Now remember, the y is being multiplied by everything in the parentheses. So to get rid of the multiplication, we divide by the whole 2x minus 5. And we do the same thing on the other side. Therefore, my equation in terms of y is 8 all over the quantity 2x minus 5. Now you'll notice I don't have a part b here because I told you that's the least important part to me right now. Okay? What's more important to me is that you actually see the process for moving things around. Okay. Second one, I want to look at number 3. Number 3, we have 2 number 3s. This is supposed to be a 5. I would suggest trying number 5 if you can as a review question for the first lesson we watched, the intro that we did in class on the first day. See if you can do that. But I want to go back to number 3. Their true number 3. They're asking you in this case to solve for y. Now the y is right here. Okay? Because the y is right here, I need to move the other quantity. And in order to move the other quantity, I have to add it since it was being subtracted. So I have 3 plus x equals 2xy. Now, before I go any farther, I can tell you right now the thought that's going through your head. Mrs. Shapanik, there are 2 x's there. And I agree. However, am I solving for x? The answer is no. And if I'm not solving for x, I don't really care how many there are. There could be 59 of them. I don't care. As long as I'm only solving for the variable that's 1. Now, if I were solving for x, I'd have to pull them out, like we did in number 4. But because I'm not solving for x, I don't care. There can be 19 of them. Get the y by itself. Okay, so I wanted to make sure I said that before you're going, wait a second. But take a look. Again, I want the y, which means I have to get rid of the 2x. 2 and x are being multiplied by y, so I divide by 2x, and I get that y equals 3 plus x, all divided by 2x. And you know what? For this stage of the game, leave it there. When we get farther and farther ahead, I'm going to make you do more with that. But at this point in time, if you can get there, I am a very, very happy camper. Okay? What I would like you to do, let me move up a minute. This story problem right here is an awesome story problem. Absolutely awesome. I want you to do number 1 on your own. You want the notes points for today. I've walked through quite a lot of this. You need to do number 1 on your own. You may use your neighbors, you can use your friends, you can quickly try and do it with some help when you get to class, but I want an attempt. I'm not saying that this has to be an absolutely correct answer when you walk in, but I want to see your thought process as we go through. And so please be aware that number 1 has to be done in order to get the notes points. If you don't, you have a max of 5, which is 0.5%, half of the points. If you do, I will give you the full 10 points, even if you're not quite on the right track, but you're trying to get there, okay? So just be aware of that as you're going through. The rest of them, you can leave blank. I'm okay with skipping a few as we go through. If there's some that you tried, like I would suggest trying the rest of them that are on there. If there's one that you tried and you said, I have no idea what's going on, please stop me tomorrow in class and we will make sure that we go through that. But otherwise, this is the end of 1-4. And again, I think you'll find you've done a lot of this in geometry, just maybe in a different capacity.